So this week, just to summarize, and so you can see where we're going, we reviewed basically how you're, for the most part, already incorporating kinematic constraints into your kinematic equations. And we just went over a special case where you have to actively think about it, right? And that was for this pulley system example. And you'll go through and practice that in your homeworks. And the important reason why we needed to go over and review these kinematic constraints and make sure we're incorporating them correctly is because we need to make sure that moving forward we have the right degrees of freedom for our system, right? We know how many coordinates we need to describe the configuration of our mechanical system. And that's important because it turns out that the number of degrees of freedom is also equal to the number of equations of motion that you will need. So moving forward, right, we've done pretty much exhausted kinematics. If you love kinematics, don't worry, we're still going to do plenty of it, but we're just going to spice things up and start to move more into understanding physical laws that govern forces. And ultimately, this will get us to our equations of motion. But this is kind of how or why it's important that we go over kinematic constraints just one last time, because moving forward, getting that degrees of freedom right for your system is important, because you need to know how many equations of motion you actually need to generate.